So, wow, welcome everybody. Hello, Jonathan, how are you doing? Hey, Susan.
Hey, Danielle. I'm going
Nice
great,
to
thank
see
you.
you. It's been a while.
It has been a long time. Since
Yeah.
it's probably a few years. Well, a few years in person, but of course I see you every week in these meetups.
Yeah, sure do. So you're in Melbourne. How's everything going in Melbourne?
Look, it feels like it's kind of getting back to normal. My youngest went off to school yesterday for the first time in what seems like months. What is months?
And you've got
Uh,
yeah. So you're working at home still, your team?
we're all bunkered away at home.
Yeah.
I guess for the foreseeable future. Who knows when?
Yeah. Well, if you can do stuff virtually, then we may as well. Yeah.
You know what? It doesn't really affect us. We've all got big screens at home. Obviously, everyone's internet's pretty good these days.
Hey, I've got a new desk. I'm standing. I've got a new standing
I
desk.
thought you were standing. It looked like you were kind of,
It's good, isn't it? Yeah.
yeah. And how do you get the camera at the right angle?
I have a little laptop set up here,
Yeah.
and then I've got my desktop here. So I'm on just on my laptop here.
Right. Yeah.
So I won't sort of do a formal introduction for you, Jonathan, but you run JPA Consulting, which is you've got a huge team. So tell us a bit about what you do.
Yeah. So we have 16 people. We're based in both Melbourne and Sydney. And look, we build and we audit financial models. And we do a bit of training, but not as much as you, Danielle. But our bread and butter is building and auditing models for project finance, infrastructure, large enterprises.
Yeah.
Anytime somebody is borrowing or raising a lot of money, debt or equity, that's when we get involved.
Great. And I didn't realize I actually know a lot of the people on your team. It's a small world, I guess.
Probably Bing. Everybody knows Bing.
Yeah. So you're going to tell us how to speed up our financial models today. Yeah.
Danielle, we spend so much time looking at models that we get from clients that are slow and clunky and cumbersome, and it's so frustrating because there are so many better ways of building models that are quicker and sleeker and neater. So I want to touch upon a few things today. Look, we've only got, I don't know, 40 minutes or so we're only really scratching the surface here. But there are a few kind of quick wins that people can go away with today and put into their models, and hopefully see a noticeable improvement in speed.
Great. Looking forward to it. I've got a few things. So do you want to share your screen? And
yeah. So just before I'll just say a few things. The focus today is on making Excel faster, so faster to calculate. So the examples I'm going to use are very, very simple examples. Okay, there's nothing complex. I don't want people to kind of get blinded by really complex examples on screen. So it'll be really, really simple examples, and they're also the type of things that normal finance people will probably use on a regular basis. So we'll be looking at lookup functions. We'll be looking at SUMIFS and SUMPRODUCTs and even simple sum functions. So things that all finance and Excel users will use on a regular basis. Now, the models that we're looking at, the examples I'm looking at, are generally in raw, pure Excel. So I'm not looking at things like Power BI, for example, because that's a whole different world. Or even things like Power Query within Excel. So some of the examples, if you're dealing with a lot of data, Power Query is great. And Excel is very, very powerful these days, Power Query. But I'm just looking at pure financial modeling examples that you'd see in a three-way financial model, or even just in what I call one-way modeling. So maybe just a kind of in fact, we're seeing a lot of it at the moment where companies are doing short-term cash forecasts. Maybe a 13-week rolling cash flow forecast where the only thing that matters is cash. The balance sheet.
So by one-way modeling, you mean just the cash flow? Just the
cash flow, yeah. Because frankly, at the moment, who cares about the P&L or the balance sheet? If you haven't got cash, then unfortunately, a lot of companies are in that way. So I'm just going to open up into okay.
Great. Yeah, we can see your screen.
Great. Okay. So what I'll do actually, I'm going to use a few different workbooks, but they all use the same kind of framework. And I'll quickly explain the kind of calculation workbook I use the first time around. So a lot of the things you'll see, I've got this box which is iterations. In this case, it's 100, So I'm going to loop a lot of these calculations with a macro, so that to make Excel calculate, in this case, 100 times. Because what I'm looking to do is I'm looking to find out which formulas take a long time to calculate. And sometimes that might be in the context of a goal seek. If you're using Excel's goal seek, you might be using Excel's data tables, and your model might be iterating a few times. Shock horror, you might be using circular references. Hopefully not, but some people do. Or you may even be using a macro to iterate the model, maybe to use a copy-paste macro to get around some circularity. There's lots of different ways people force Excel to calculate the number of times. So I'm just kind of simulating that by running a macro to do that. Now look, in this case here, I've got this random number here. I've got a random number which is between 1 and 10,000. So every time I calculate, I'm pressing F9, that just changes. And I've got a lot of data in this column A and column B on this sheet. Now, column A, I just happen to have the numbers between 1 and 10,000, just not sorted. And column B, I've got the same number, but with a hash mark in front of it. So what I want to do is I want to look for, in this case, the number 1373. And I want to look for that in column A and return whatever is in column B. Now, I know it should find 1373 in column A, and it should return hash 1373 in column B. Now, lots of different ways of doing this. Everyone's got their favorites. And I think, Danielle, we might have a quick poll about which kind of lookup you would use in this situation.
Yeah, so everyone let us know which one. What do you think would be the best way of doing this? Okay, wow. Yeah.
Oh, it says at the bottom, hosts and panelists cannot vote. So I was going to.
Oh no! Yeah.
I was just going to vote on that.
Yeah. So we've got.
Yeah.
Now,
those are not the only ways of doing it. It's the beautiful thing about Excel, as you know, Danielle. There's always a million ways of doing things. Okay, so anybody who ever stands up and says this is the only way to do something, well. It's wrong. There's always multiple ways, but these are certainly three. Well, index match and VLOOKUP are certainly two of the very standard ways that have been around for many, many years. XLOOKUP is obviously a whole lot newer, but we'll take a look at that.
But yeah, I'm interested to know about the speed between them. So I'm going to stop that poll now, and then I'm going to share the results. So you should be able to see. And it seems like index match is the winner. Most people think that index match is faster. VLOOKUP is next, and a couple of people had no idea, and about 20% of people thought that XLOOKUP.
Okay, well let's quickly jump into it. Okay, I'll put in index match. So I'm going to, if I can type properly, it's really cold here in Melbourne, so my hands are so cold, so my typing might be a little bit, so index match, just going to look at, come on, computer, don't freeze now. Yeah, arranged there. In fact, I'm going to make a column B because I want to return column B. Okay, and I'm going to use a match. And I'm going to look for this guy here. And I'm going to look for that in column A. Now, because that data is not sorted, it's kind of very randomly sorted. So I need to put a 0 on the end there to find an exact match. So that's a very, very standard index match. And you can see that we're looking for, in this case, 7584. And it's returning hash 7584. So we know it's working. If I press F9, get a new random number, it gives me the right thing. Okay, so that's it. I'm just going to copy that across for 1,000 cells. So I've got 1,000 lookups, and they're all doing the same thing. And when I hit this macro, it's going to calculate 100 times. And 100 times is going to change the random number. Now I've got screen updating to false here. I've just got a little drop down, so I can set it to true or false. false just turn screen updating off for the macro, makes it run a little bit faster and make sure that we're not kind of, we're not tainting the calculation speed by having to update the screen. So I'll press my macro. Hopefully this won't take too long. Let me just move that poll. Okay. I don't know if you can see that, but it says 2.6 seconds. So pretty quick. I'll just write down here.
So you mean the speed in calculation, yeah?
Yeah, so that took 2.6 seconds to do 100 times.
Cool.
What about VLOOKUP? Now, VLOOKUP is pretty simple. VLOOKUP for this thing here again, F4. We're going to look for it, of course, with VLOOKUP, we need to say the whole range. The whole range. And we need a 2 because it's the second column that we're returning. And we need a false in the end because the data is not sorted. Now, this is one of the beautiful things about the new Excel is that we get these hash spills all over the place. So there's a few different ways of getting around this. One of them is that we can put a ampersand. There you go. I hate the way it does that. Let's see if that.
Just pop the comma in there, yeah.
Yeah. There we go. So that's our VLOOKUP, and it's only that one cell right now. It's giving us the same number as the index matches, so we know it's the right formula. I'll just copy it down and across, and check it's all working. Okay, again, I'll calculate this 100 times. And that's 2.3 seconds. So that was faster than index match.
Wow, interesting.
Now, know that many of you looking at this have seen lots of the kind of talk around the internet of well, recently with regards to XLOOKUP, but more generally over many years, people keep saying VLOOKUP is slower. It's not. It's faster. Now, VLOOKUP is not great for other reasons, okay? Principally because you can only really look to the right of the column that you're searching. So you're searching the first column and you look to the right. There's a few kind of things you can do, clever things to get around that, but essentially that's its main drawback. But it is not slower than index match. Definitely not. I've tested this to death. Big data sets, small data sets, it is at least as fast as index match. But two reasons I generally don't use it. One, it's the inflexibility of looking in the first column. And two, we can make index match a whole lot faster. Much faster.
We have a question about VLOOKUP. So why would you, there's no reason why you would ever use a VLOOKUP now that we've got XLOOKUP. Is there any reason?
Well, let's move on to XLOOKUP, okay? Because that's a really good point. Of course, some of us have XLOOKUP. Unfortunately, Microsoft are using these new functions as a bit of a marketing ploy. There's basically two types of new functions. The dynamic arrays, which are only going to Office 365 or Excel 365, whatever they're calling it. And then there are some of the newer functions, the non-dynamic arrays, which are slowly being rolled out across the Excel universe. So of course, not everybody has XLOOKUP available. And it seems like now almost on a monthly basis, they're releasing new functions. The latest one, and I think Oz looked at it last week on his, was the let function. But anyway, let's quickly jump into XLOOKUP. The syntax for XLOOKUP is a little bit different. I'll type it in here, equals, and XLOOKUP has a lot more options. So we're going to look for this one here again. We're going to look for it in this range. We're going to return column B. Check out my anchors, right? Now, one of the great things about XLOOKUP, it has this if not found. So I must admit, I haven't actually put anything into the if not found, but that can be quite useful if you think there's a chance that the data won't be there. But we'll leave that blank for now. Now, this is the first main option. We can go exact match or exact match next smaller item. We're going to go for an exact match because the data is not sorted. We want to make sure we're finding the right item. And then this is the biggest advantage of XLOOKUP, I think. You can say search first, last, so top to bottom, or from bottom to top. So if you've got a lot of data, that could be quite useful. But in this case, we'll just go search first to last. Okay, and that's my XLOOKUP function. And again, it's returning exactly the same number as in this case, VLOOKUP. So I'll copy that down and across. Check it's all working okay. And I'll calculate this for 100 times. So we have 2.6 seconds for index match, 2.3 for VLOOKUP. Look at that. That's 3 seconds for XLOOKUP.
Wow.
Yeah. Now that's, by the way, I'm working off a fairly normal laptop at the moment. I think it's got like an i5 7th generation CPU. I sometimes work off a faster desktop. And the speed differential is pretty much consistent across all the machines I've tried this on. So index match and VLOOKUP, normally they're around about the same speed, and XLOOKUP is 10 to 20%.
Yeah, we're getting a lot of questions about the 64-bit versus stuff like that, but we might
yeah, look, if we had 3 hours or 4 hours for this, we could talk quite a bit about that.
Exactly. There's just an interesting conversation going on in the chat with Nathan and Dan that we both know. Just saying that, so Dan's saying if you were to do the test with the match only once and having the 1,000 index formulas looking at that single result, that would make a difference. Absolutely.
And that's the next thing to go on to. And this is probably the single biggest time saving. So if I go back to the index match, I wonder if I probably can't undo all the way back there. There we go. So it's back to the index match. And in this case, we've got 1,000 lookups. So we have 1,000 match functions, but they're all doing exactly the same thing. So what I like to do is I like to use what I call a helper cell. So I'm going to take this match portion of the index match, okay, and I'm going to copy it and pop it into here. And then in each of these lookups, instead of having index match, we're just going to turn it into a pure index. And I'm just going to refer to that cell there. So now we only have one match, and I'll just copy that down across. So now we've got 1,000 indexes and only one match. And the speed differential should be quite huge. So that was 0.13 of a second.
Wow, yes.
And this is why index match is still, or if you like, pure index, is still the way to go. So if any of these kind of lookups, index match, especially if you can take the match out. Now, not every situation you can take the match out. So you'll often have a formula which is copied across a row, looking at a timeline, and it's each formula is looking at, the match is looking at, say, a separate date. So you can't necessarily take it out that way. Or it might be copied down a column, and it's looking at a separate column lookup. But if you can take the match out and just have a pure index, then the speed difference in your model is enormous.
Yes, and that's the same with the volatile formulas, which I know you're going to cover as well.
So we're going to move up to now. Yeah, yeah. One thing, just to wrap up on this. This is the, so we looked at XLOOKUP. I don't think XLOOKUP is going to take off. I just think there's a lot of hype around it, and I don't think it's going to work. What I do think is going to take off is the X match. So instead of having the traditional match formula, we have the X match, which is very, very similar, but it gives you all the options that XLOOKUP also gives you. And it's, at the moment, it's still a bit slower. So with these new Excel functions, Microsoft has been releasing them almost in beta form. So I think the XLOOKUP has been through about 3 releases so far. Now, to be fair to Microsoft, each release has got better and each release has got faster. When I first looked at XLOOKUP maybe 3 or 4 months ago, it was noticeably slower. So that I think they've speeded it up. X match is still a bit slower than match, but maybe Microsoft will speed that up. Maybe Joe McDade, who's kind of a Melburnian, but running Excel now, maybe he'll get onto that. Yeah. Joe, if you're watching,
yeah,
speed up X match.
That guy in Microsoft, yeah.
Yeah.
Right, so with the voice of the modelers.
So look, yeah, absolutely. Just to summarize that, index match is still very much my favorite. It's still very much the industry standard, I think, for these kind of lookups. No need to use VLOOKUP. VLOOKUP is definitely inferior in terms of flexibility, but it's not slower. Not slower. Except, of course, if you can take the match out, then nothing is as fast as just the raw index. Okay, let's move on to the next topic, which is, as you mentioned, Danielle, volatile functions. And this is another favorite of mine. I'll just close this and share another screen. Okay, so this is a big file. It's just going to open up. It's going to take a little while to open up, and then I'll share it. But volatile functions are something which...
Do you want me to launch the poll about volatile?
Yes. Yes, please, Danielle.
Just a question whether you use volatile functions in your models. So the responses are yes, no, sometimes, or what is a volatile function? So it's anonymous pretty much. So just interesting to see, what people say. So yeah, no big deal what you respond, just to kind of get a bit of a feel for who's on the call. And yeah, interesting. Okay. Wow, we've got like nearly 180 people online right now. So
what would hopefully this won't influence anyone's vote, but volatile functions are the one thing that you can really mess up, or one of the many things, but one of the most common things you can really mess up a model with. Volatile functions, there are about 8 or 9 functions in Excel that are called volatile. And if you haven't experienced these before, what that means is that they're always on edge. They're always looking to calculate. They're always looking to recalculate. Now, most functions in Excel aren't volatile. Excel's got
the results now. Most people said, what's a volatile function? So I'm glad you explained it.
Yeah. So let me look at this example. Now, if we think about, let's think about a kind of a financial model, which is a 3-way financial model. So we've got an income statement, we've got a cash flow, and we've got a balance sheet. And you've got inputs. And so hopefully this kind of comes through, okay? So, but for example, in my model, if I change an input for depreciation, so if I change my depreciation inputs, what happens is the depreciation in the income statement changes. Actually, net profit should change as well, as shown there. On the cash flow statement, nothing changes. And on the balance sheet, fixed assets and equity will change. But changing the depreciation inputs doesn't affect my debt calculations. It doesn't affect my cash flow in any way. It doesn't affect my revenue, et cetera, et cetera. Similarly, if I change my tax assumptions, it changes tax, net cash flow, equity, but it doesn't touch, you know, the operational side of the income statement. It doesn't touch my revenue, my working capital, etc., etc. In Excel, when Excel has a thing called a calc chain. Now, what it does, it remembers what cells change whenever you change an input. So if you change your tax input from 30% to 28%, Excel knows that it should change tax calcs and it should change its cash flow. It should recalculate them, but it knows that it doesn't have to calculate your CapEx because Excel knows that CapEx is not affected by your tax rate. And so when you change the tax rate to 28% and you hit F9 or you have automatic calculation turn on, it doesn't bother updating the formulas in your CapEx section or your revenue section or your cost of goods sold section because it knows they're not affected unless you've got volatile functions. And if you have a volatile function, Excel always recalculates them. So whenever anything changes in the model, Excel always recalculates your volatile functions, even if they don't need to be calculated. And not only that, it will then subsequently calculate everything that's downstream. So looking at this example here, if I change my tax calc, my tax inputs, but I happen to have a volatile function in my inputs for my sales volumes, Excel will also calculate those calcs, and that will then flow through to my revenue, my costs, my gross profit, my EBITDA. All those bits of the model will calculate as well. And so let me kind of show you a live example of this. On this model, I've got 5 big sheets, okay? Now, each of these, they're called first, second, third, fourth, fifth. And each of these has 1 million calculations, okay? So on the first sheet, every one of these cells just simply refers to A1. On the second sheet, it's the same. Every one of these million cells refers to cell A1. The third sheet just simply multiplies the first by the second. The fourth sheet and the fifth sheet simply multiply the sheets together. So I've got 5 million calculations, all flowing from, in this case, cell A1 on the first sheet and cell A1 on the second sheet. And those two formulas link through to these 2 cells here, these 2 seed cells. So everything in this, I've got 5 million calculations, and they all start from these 2 cells. Yeah. At the moment, they're just hard-coded to 2. So if I calculate this model 10 times, it's just going to calculate 10 times. It's a cell. It's nothing. It's just instantaneous. If I change these 2 cells, I'll put a 5 in. Calculate, and now I'll calculate it. It took 1.265 seconds, a bit slower, because there's 5 million calculations. That's fine. And if I calculate it again 10 times, it's instantaneous because I haven't changed the 5s. So Excel knows that it doesn't have to calculate those 5 million cells because nothing has changed. But look at this, completely unrelated to those 5 million cells. If I type in equals offset, offset that cell, just a blank cell, comma 0, comma 0. So that offset formula is just sitting there all by itself doing absolutely nothing. Calculate 10 times. And there you go. It just took 7.5 seconds.
Wow. And that's why we don't use offset.
That is why we'd never use offset.
Among other reasons.
So offset is the main one. Indirect is probably the other main commonly used volatile function.
We had a question actually about that. Do you have any other recommendations besides an indirect?
That's a very good point, because indirect is very powerful and very useful. And you often get indirect used in an example where you might have a model with 10 or 20 or 30 different divisions or subsidiaries, and people have those modeled on different worksheets, for example, and they use the indirect to pull through the relevant cells. So we try to, well, we do avoid it at JPA by just using more direct formulas. You know, and we'll structure so that we have formulas linking to the actual worksheets rather than using it indirect where possible, because it produces the exact same effect as this.
Cool.
So please avoid now. Look, offset itself is actually a fast formula. So if you have a big chunk of data and you need to do some kind of lookup function. Let's say you've got, you know, a million rows or whatever. Well, if you have a million rows, you should be using Power Query. But let's just say you need to use Excel, a normal Excel function. And it's just a one-off calculation. Offset is quite quick. Offset's even quicker than index for a one-off calculation. But in the context of a bigger model, it's a disaster. So please avoid it.
Were you going to talk about today? The today bracket function?
I wasn't, but that's another one. So today,
just had a question about whether, yeah, John just mentioned if you were going to use it a lot, you would create a named range and then refer to that, and that's something I definitely recommend. Do you agree that it makes a bit of difference?
I don't know. Actually, I've never tried that. So just putting what today into a named range and referring.
Yeah, so linking to one, whether it's a named range or not, but just linking to the one cell rather than putting the today inside the formula, because it just makes the.
Oh yeah.
I think that was something actually I picked up from, you ran a session in Melbourne years ago, and I learned so much from that. And I think that was one of the things that you mentioned then.
All right. Yeah. I remember the session. I can't remember that specific example, but yeah. But even as I've shown here, we've got 5 million formulas and only one offset, which isn't even part of the kind of the flow of calculations. messes it up. So please avoid volatile functions where possible.
It's certainly if speed is an issue.
Yeah. All right, now because time is going to get away from us, we'll move quickly on to the next another kind of very, very common function, which is just close this. That's a big file, so it's going to take a little bit of time to close. Now this is something which some people kind of get a little bit, dare I say, emotional about this next topic, which is SUMIFS and SUMPRODUCT. Now, the SUMIF function and the SUMPRODUCT function have been around for forever, and the SUMIFS, so SUMIF with an S on the end, came out 3-4 years ago, Danielle, I think it was, and they're all very, very useful. The SUMPRODUCT function is super powerful. It can do so many things, and a lot of modelers who are far more clever than I am do some really powerful things with SUMPRODUCT.
Shall I launch the next poll?
Yes, please.
So just
yeah. So what I'll describe what I'm doing here. So I've got in column A, I've got 10,000 items, and they're just going to go in this case. And there's a subtotal every so often, which just subtotals. Obviously, there's a subtotal in column B of the value in column B, and I just want to do some kind of SUMIF type or subtotal in here. So I want to sum up all of the subtotals from column A. So as we've got quite a few. We've got 10,000 items plus all the subtotals. So we've got 12,000 rows, and we want to sum up all of these red subtotals. So.
Wow, we got some interesting results. I'm going to stop the polling in a minute because, yeah, most people, it's kind of a neck and neck between SUMPRODUCT and SUMIF, or SUMIFS and SUMPRODUCT. Yeah. I'll just share those results because, yeah, SUMIFS is the winner. Most people think that SUMIFS is faster, so closely followed by SUMPRODUCT, and a few people have no idea.
Fair enough. Yeah, that's probably not surprising. I wonder if that'll change after we look at this. So look, just to speed things up, I've pre-prepared these formulas. Some if copy that across. So the SUMIF function, the kind of traditional, and what we're doing here is we're looking at column A, column B, and in column E, we've got the item that we're searching for. So we're summing up all these rev subtotals, and I'll just copy this down. So again, this is just an extreme example to demonstrate the speed difference. I've got 5,000 of these SUMIF functions. Actually, 5,000 is not that extreme. You know, Danielle, in the financial models that we do at JPA, we usually count how many functions are in each model. So we have a little tool which says, you know, how many match functions, how many index functions, how many sum functions are in the model. And it's quite normal to get over 1 million functions in a financial model. 3 million
functions, surely. Just
no, not unique. Unique, you know, in unique formulas, you might get anywhere between 2,000 and 6,000, typically, sometimes way more. But yeah, in terms of actual functions, so one formula copied across 50 columns is 50 functions. Over 1 million is quite common, and up to 2 or 3 million is not that unusual. And so in this case here, 5,000 SUMIFs is far from extreme. So again, using my macro, I'm going to calculate this 10 times. And all the macro does is in column B, it just changes these 10s to a 1, 2, 3. I think I'll leave screen updating on. I'm not sure how that's going to look across Zoom, whether you see that updating or not. I'm not even sure it is.
Yeah, it's just thinking.
It's frozen on 1. There we go. So
it took a while.
15 seconds. Yeah. It's a lot of calculations there, and I think having the zoom on does take away a bit of the calculation overhead. So that's the regular SUMIF. The other function we could use is SUMIFS. Again, I'll just copy this across, split things up. Personally, I now always use SUMIFS.
Yeah, because even though you may not need the extra criteria, it's a real pain to have to change it later.
And I just think the syntax of SUMIFS is better.
Different.
Yeah, they flipped it around, and it just to me, I think it's better to use. So
but is it faster is the question.
Yeah. Look, there you go. So that's 14.9 seconds. So look, with these calculation tests, they're not always the same. There's a kind of bit of tolerance on either side of the calculation. So SUMIF was 15. SUMIFS is essentially 15 as well. I find that in my testing that they're about the same speed. But what about SUMPRODUCT? That's the key question. So just the opposite. SUMIF and SUMIFS, same speed. Use SUMIFS because it's better. It gives you SUMIFS takes nothing away from SUMIF, gives you more, and it's so why not use it? SUMPRODUCT. Now I know that not everybody is familiar with the minus in the SUMPRODUCT. That's just a way of forcing it to be a true or false. So I've got my 5,000 SUMIFs and going to calculate that. And it feels to me like it's definitely slower. Wow.
Yeah, it's certainly taking
it is. I think it looks like it's almost done. Or is it? It's still thinking about it. Oh, there you go.
Anyway.
32 seconds. And that's pretty consistent with the other testing I've done, where SUMPRODUCT takes In this case, about twice as long as SUMIFS. SUMPRODUCT is fantastic if you've got a small matrix of numbers that you want to multiply. It's really, really great for that. But for a big subtotaling, sum-ifing type of function like this, it's really best avoided. Of course, the other thing about SUMIFS and these SUMIF is that you can do whole column references, which is great. So that if I go back to I'll just copy it across here, take my SUMIFS, and I can use this formula here. Depending on how your model is set up.
Doesn't that really slow things down?
Well, no, it doesn't. With my SUMIFS, I'm referring to all of column A, all of column B, and all of column E. And I've got a little asterisk, at symbol in front of E to stop it being a spill. And it slows things down very slightly. But honestly, you wouldn't even notice it. I think it adds like maybe 2, 3, 4% to the calc speed. So not noticeable, but it can be a lot more useful. Because, especially if you're not using tables, you often don't know where the bottom of the range of data is.
That's the question that's come up from Cole. How do the Excel tables?
Well, that's the next thing to move on to. But I'll just run this 10 times. So we had around 15 seconds for the regular SUMIFS. This was 10 seconds. So look, I think possibly sometimes the Zoom makes things. When I've tested it before, it hasn't been quicker. Whole column references have not been quicker, but they're usually around about the same speed. So
for everyone that's making comments in the chat, we've got tons and tons we've got so many people on it. We're not going to be able to cover everything, but if you want for everyone to see your comments, you need to change the drop down to everyone, because we're getting a few questions that are only coming to us.
Yeah. So upshot of that, Danielle, is that for SUMIF and SUMIFS, whole column references, they're no slower, and they can be more useful, provided, and this is the key thing, in this case here, my data goes down to row 12,000. And as long as that's the end of my data, so I've got nothing below there, it's fine. If for some reason I had stuff way down in the millionth row, then it would slow it down considerably.
Because then it's going to go all the way down.
Yeah, because Excel will look at the used range. So Excel, in this case here, if I press Control End, it goes to N12006. So Excel knows only needs to cover down as far as row 12,006. And therefore it stops. Now I won't do it because it will just clock up my computer. But SUMPRODUCT never do whole column references. It will take literally minutes and minutes and minutes to calculate. So SUMPRODUCT, great for small references, 10, 20, 30 columns or rows. It's superb. SUMPRODUCT, you can do some really funky things with it. Really clever formulas with SUMPRODUCT. But for big data sets, it's just not useful.
Yeah, I've got a question from someone saying, shouldn't we use subtotals? Subtotals. I don't use subtotals very much. Do you?
I think I've used it once.
Yeah.
About 10 years ago, maybe. Better. Yeah. In a financial model, we always want to avoid those kind of structural things. We want to keep it as simple and as formulaic based as possible. Yeah. So, for example, in a financial model, we would financial model that we build, we'd never put in pivot tables because they're just too static.
Yeah.
For example. So the question then is about tables and Excel's table function. And I think you covered this off with, I think we were on the call with Oz de Soleil last week, Danielle, where you mentioned that a lot of people don't use tables. Tables are fantastic, but they have a big drawback.
But a bit, yeah, like a pivot table and a table for analysis.
I actually mean like a kind of let me go back to the lookup function. In the lookup example, just running this now. this is the lookup example before, where you see, index match and VLOOKUP and XLOOKUP. But the data now I've turned into a table. And to turn anything to, by table, what I mean is that it's what Excel calls a table. So it's got
a table with a capital T.
Yes. So if you've got a whole lot of, for those who haven't done it before, if you've got a whole lot of numbers and you've got, I don't know, categories across the top, and that will be kind of, if I just hit Control T, that turns into a table. And like I say, my table has headers. And then you can refer to that table. And the beauty of that is, of course, that if I type in equals sum, and I just use that there, that sums that up. But if I come along and add another row of data, it should, if I press F9 and calculate, it automatically updates the rate. So that's the greatest thing about tables. But they're slower.
Are they?
They are slower. I'll just delete all of this. So in this case here, I've got my exact same data as before. And to do, on the other thing as well is, and this is my personal opinion, Danielle, I don't like them. I hate looking at formulas that are written as tables. Some people love them, and that's great. But for me, it's, so if I was writing an index match to look at this, what I do is equals index, I go to my table, and I want to return this column here. So I do that. And then I say, comma, match this item, and look for it in that column there, comma 0. So that's my index match in a table format. Some people really like the fact that that's written essentially in English, and you can kind of, as long as your table has got headings that make sense, you can kind of look at that and say, yeah, I know what it's doing. Personally, I just find them ugly, to be honest. But I'll copy it down, copy it across, check it's working okay, and I'll calculate this 100 times. So that was 2.2 seconds. I can't actually remember what we had time-wise for the regular index match, but it wasn't, certainly wasn't a whole lot quicker than that. So tables aren't quicker; they can be slower.
Someone said somebody has an elephant memory. We had 2.6 apparently.
Oh, there you go. So it was a bit faster. But when I've tested it quite a bit, and they're generally slower. But they are very, very useful. They're really useful because they're complete. So I know if I come along to the bottom of this row, this table, and add more data, any formula that uses a table notation will pick it up automatically. Whereas if I'm using just normal Excel row and column references, it won't pick up any extra data. So that's the single biggest advantage of tables.
Personally, I only use tables when you've got large quantities of data for sort of data analysis and dashboards. For financial models though, sometimes you have got large quantities of data in a model, but I think the fact that you can't have formulas in the titles just drives me insane. And
I agree, Danielle, completely. So yeah, absolutely. For ad hoc analysis, they can be quite good, but a three-way model, I avoid them like the plague. And just conscious of time, one last thing to definitely, really, the simplest formula of all, well, arguably the simplest formula of all.
There was a couple of questions about whether we're going to make, are you going to make this available, Jonathan?
Yeah, all these files, I'm happy to make all these files available. They're all super simple. Certainly the macro I use for calculating the speed, some people might want to see that, so we can certainly.
Yeah, there was a bit of interest in that.
Yeah, definitely. So we'll definitely send it around.
Recording.
Yeah, the rest of the examples are they're just very, very simple. So if anybody wants them, they can have them, but there's nothing to them. I deliberately use very, very simple data, all of these things. This is what I'm going to share now is the cumulative sum, or the expanding sum range. So what I'm looking at here,
I use this one a lot.
Oh yeah, so I've got 10,000 items, okay, and at the moment each item is just 1, but every time I iterate my macro, that's going to change to a 2, and every other item in this row just refers back to the cell to the left. So if that becomes a 3, then they all become a 3, for example. Okay, and then we have in in row 10, we've got an expanding sum range. So if we go across to column H, it's looking at 4 cells. If we go all the way across to column NTT, not often you say column NTT, we're looking at all 10,000 cells in row 7. So these kind of expanding or cumulative sum totals are fairly common in various different modeling tasks. And if I calculate this 10 times, so by calculating 10 times, the items in row 7 are going to become a 1 and a 2 and a 3 and so on. I've got screen updating turned off. Let's see how this goes. I hope most people on this call are in somewhere where it's warmer than Melbourne. It is absolutely freezing here. Okay, so that was 17 seconds. Now it's really interesting because having the zoom on your computer really slows things down, because I was testing this yesterday and I'm sure it was about 9 seconds.
But presumably they're all similarly been slowed down by Zoom. Yeah,
absolutely. So this is one of the single biggest savings you can get in a financial model, is that instead of having this kind of cumulative sum range, you just say, well, equals, in this case, E7 plus, not 37, E7 plus D10. And you just copy that across. And wait for the update.
Yeah, but the formulas are inconsistent.
Well, the first formula is referring to a blank cell, which so this formula here is referring to a blank cell. And you can kind of come now, you can put a shading on that cell or some kind of indication, but it's the same formula all the way across. And now I'll see what it's, if it's any faster. There you go, 5 seconds. So that was quite a bit faster that way. And the reason it's faster is that under this method, I've still got 10,000 formulas, but each of these formulas is only referring to 2 cells. So even the last formula here is referring to 2 cells, whereas in the previous method, the last formula was referring to 10,000 cells. So on average, each of these formulas in this row were referring to 5,000 cells, and we've got 10,000 of them, so that's 50 million cell references compared to 20,000 cell references under this method. So if you're doing a kind of a cumulative sum method, if you can use this kind of technique, it's far, far faster than an expanding sum range.
Interesting. Yeah.
Danielle, how are we going for time?
Yeah, we have got 4 minutes left. So we scheduled to have an hour for this session.
Yeah.
I realize I've tried to sort of jump in some of the questions. I'm just aware that there are tons of questions that we have not had a chance to address. But we've got our face-to-face session coming up. Susan has just popped the link into the chat window.
Can I do one more thing?
Yeah, sure. And then we'll jump and we'll do some of the questions then in
Yeah.
the
Okay. I'm just opening this up now. This is how you use an if statement to speed things up. Okay, so quickly share this. Okay, so in this model here, I've got a whole bunch of index match functions. So I've got 57,600 index match formulas, and all they're simply doing is they're looking at the division name in column B, and they're looking at the date in row 7, and they're pulling through the relevant number from this table of data on this other sheet. So index match, looking at the relevant data. But here's the thing, I've got this little drop down here, which picks a date, and I only care about the numbers for this column. So whatever this might be a transaction date, or it might be a disposal date, whatever it might be, I only care about, in this case, the numbers for the month ending 30th of November 2020, which is there. So I've put a little kind of a flag here just to say, well, if this is the month that we've selected in our drop down, then put a flag there. Now, and so I care about these numbers here in column O, but I don't care about all of these numbers here, and I don't care about all those numbers here. So what we can do, the way not to do this is to say equals index match, multiplied by that. And that turns it to 0. I'll just put a dollar on row 8. Okay, so now we see it's only giving us the numbers for the column we want. However, it's still calculating all the rest. All of these are still calculating, and they're just calculating and then giving us 0. Far better way of doing this is to use an if statement instead of multiplying by the flag. So we'll get rid of this multiply by a, and we'll say before the index, if, and this is a 1 or 0, so we can just say if that, lock it on row 8, if that, then give me the index match formula, or else give me nothing. And copy it down across. Still giving the same result, but it does not calculate these formulas. Oh, so it doesn't calculate the index match portion of these formulas. Now, I'll just quickly calculate this 100 times just to see what that looks like.
I see what you mean, yeah.
That came through 0.32 seconds. And we haven't got time, but trust me, if I did that without having the if statement,
yeah, because
it's a lot slower
before the if statement, and so then it doesn't calculate the whole thing.
That's right. Yeah. It says, well,
I still like the flag because it's simple for people to follow. I guess that's
yeah. And look, Danielle, all of these things I've shown today, okay, if your model already calculates quickly, don't worry about it. There is no problem using SUMPRODUCT. There's no problem using any of these things as long as your model is fast. But if your model is slowing down, getting a bit sluggish, you know, maybe you've taken it onto manual calculation because automatic calculation just is too annoying. Then start having a look at these things.
Yeah, cool.
And definitely, if you use any kind of looping in your goal seek data tables or a looping macro, then that's when you really want to start having a look at the speed you can save.
Thank you so much, Jonathan. That was
my pleasure.
Fascinating. We are out of time, so I'm going to close down this session. For those of you who are planning to join us in the private face-to-face session, Susan has just posted the link again. There is a password. It is not going to be recorded. So if you have more questions, I'll have a quick look at some of the Q&A. I know we didn't get to all the questions, and see if there's some that we could address that JP will have a chance to address. So I will see you all in there. Otherwise, I'll see you again next week. We are doing Monte Carlo simulation. This one is actually being hosted by CPA, so you need to register with CPA for that one. So it's a little bit different. It's not going to be via Zoom. So I'll see you all then. See you later. Thanks, Jonathan. I'll see you on the other side.